Hello viewers, welcome to another section of my tutorial, and I have a problem in AC theory, which is a topic in applied electricity. So it says a capacitor of 400 over pi microfarad, that is the value for the capacitance, is connected in parallel with a 40 ohm resistor across a 200 volt 50 Hz supply. So find the supply current, then determine the power factor of the whole circuit. So to solve such a problem, you have to make a drawing. So from here, let's see, you have a capacitor here, and this is in parallel with a 40 ohm resistor. This is our 40 ohm, and this is our 400 over pi microfarad. So this whole thing is connected to a 200 volts then 50 Hz supply. So from here, what do? We are supposed to convert the impedances into the complex notation so that we can simplify it easily. So to do that, we have to find a capacitive reactance which is equal to 1 over 2 pi Fc. So when you find a capacitive reactance, then you convert it to the complex mode. So this is the same as 1 over 2 times pi times 50, but our C is equal to 400 over pi, then times 10 to the power negative 6. So from here, the pi will cancel this pi, and you'll be left with 100. 1 over 2 times 50 is 100 times 400. But the 10 to the power negative 6 will move up as 1 times 10 to the power 6. So you punch this into the calculator so that you see what you get. So we have 10 to the power 6, 10 to the power 6 over 400 times 100, and that will give us 25. So this is equal to 25 ohm. It's a reactance, so it's 25 ohms. Now to represent the 25 ohm in the complex, what we know that capacitive reactance is represented with negative complex parts. So we have 0 minus 25G or ohms as the impedance for the capacitance part. Then for the resistor, we know that it takes the raw part, so you get our R, which is equal to 40 ohm, to be equal to 40 plus 0 G ohm. Now the first part is saying we should find the total supply current. To do that, we need the total impedance, then we divide it by the total voltage to get the current. So total impedance ZT will be equal to the parallel C1 C2 over Z1 plus Z2. This will be 40 plus 0J multiplying 0 minus 25J all over 40 plus 0J, then plus 0 minus 25J. So you punch this on the calculator, then you get a final result. So set your calculator to the complex mode, then you punch this, which is the same as 40, then by negative 25I over 40 plus negative 25I. So you get 11.24, then minus 17.98, minus 17.98 I. But here we are using J. In AC, we use J because I will mimic current, so we have to use the J. So this will be our total impedance. But now, in order to make division in complex notation, you have to be, or this has to be in the, with the magnitude, and so it has to be in this mode, the magnitude, angle, the argument. So we will find the magnitude of this, and that will give us, when you convert that, that will give us 21.19, then angle, so it's 21.199, so you let make it 199 angle negative 57.99. So angle negative 57.99. So let's make it 21.2 angle negative 58 degrees. So this will be our total impedance in the complex mode. So to move further, what you are going to do is you are going to have your voltage. So our current, as the question is saying, you find the supply current I will be equal to 200 angle 0. We use the voltage as always angle 0 over 21.2 angle negative 58 degrees. So what do? You make this simple calculation and you get 200 over 21.2. So you get 9.43 amperes. So this is the total current in the circuit, or total supply current. That is 9.43 amperes. Now let's go to the B part, which is determine the power factor of the overall circuit. So now from the answer, this 9.43 is the magnitude part. So you have 9.43 angle 58 degrees. That will be positive because you have 0 minus this. Now in complex mode, if you have this, is this minus this. Sorry, this divided by this. But the argument will subtract this one minus this. So you get positive. This minus this. That will give us this. So if this is the magnitude of the current, this will be the phase difference between the current and the voltage. To determine the power factor, that is PF, of the entire circuit is equal to cos theta, where theta is the phase difference. And from the question, the phase difference was 58 degrees. So our power factor is simply cos 58 degrees. So that will simply give us, so cos 58 degrees. So you have cos 58. That is 0.53. So that will give us 0.53. Now, it was positive, so it is leading. Now, when you are being asked to find the power factor, you have to indicate if it's leading or lagging. So depending on the sign, if it's negative, then it means it is lagging. If it's positive, it's leading. So you say the power factor is 0.53 leading. This is the end of my video. Thanks for watching. Kindly like, subscribe and share, and so that you'll be notified when I post similar videos. So please follow. I'll be posting similar videos more about AC theory, so don't miss those opportunities. Thank you.